In today's lesson, we will be learning the final method that you can use to solve a system of equations, and it's called elimination. So just to remind ourselves, like I said, there's three ways to solve a system, which is just two linear equations. The first way that we learned was by graphing the lines. I'm going to make a little note underneath each method of kind of how we want the system to look. So if you remember, for graphing, we want both equations to be in mx plus b. The second method was substitution. And remember, for that one, we need a variable alone. Doesn't have to be mx plus b, little bullet points. Just have to have an x or a y somewhere within the system that's alone. And the third method is called elimination. And we're going to explain what the setup needs to be in your system to be able to use this method down here. Alright, so if you think about what it means when you eliminate something. If you eliminate it, you get rid of it. So that's what we're going to be doing when we use this method. And we'll kind of fill in this sentence here. What you do is you add, that part's important, you're going to add the equations, because I know there's two, together to get rid of one of the variables. Or in other words, you're going to eliminate one of the variables. So to do this, and we know like the setup mattered for the other two methods, so of course it matters for elimination as well. So to be able to use elimination, the coefficients. Now, if you don't know what that word means, like a term, so this 5x right here, that's a term. The coefficient is the number that sits in front of the variable. So it's just the number in front of like the x or the y. So the number in front of the variable that you're trying to eliminate must be the same number, but it must have the opposite signs. And I'll show you exactly what that means on all these examples, but basically I need the same number with different signs. So one of your terms, one of your coefficients has to be positive, one has to be negative. So that's kind of wordy, but honestly, you guys, it's not terribly complicated. We're just going to jump right into some examples. So if I look at example 1 here, and if you remember for substitution, the first day we did problems that were set up nicely for substitution. And then the second day we went in and we did more challenging examples that weren't set up nicely. We're doing that same thing with elimination. So all of these are pretty much going to be set up nicely. So example 1, notice that both of these equations are in standard form. We don't want mx plus b on these, we want standard form. What are the coefficients for each variable? Well, again, that's just the numbers in front. So in the first equation, I've got 5 and I've got 3 in front of my x and my y. And in the second equation, if a number's not there, I know that it's just a 1. And then in front of the y here, it's negative 3. Take the sign with it. So again, coefficients, just number in front of the variable. Now it says, well, which variable are we eliminating? Well, let's look back up to this bullet point here. The variable that's going to be eliminated is the one that has the same number, but one positive, one negative. So check out the y's here. That's exactly what I mean. In front of your y's, they're 3's. One's positive, one's negative. So if I add these equations together, the y's are going to eliminate. And they're asking why, and we're about to do it, so you'll kind of see it happen then, but it's because there's the same number, and I abbreviated their number, and one's positive, one negative. So it's the same number, one positive, one negative. So watch what happens. What I'm going to do is I'm just going to leave it all how it is, not going to move anything, and I'm just going to add these two equations together. Jump over to the y's. Here's why the y's eliminate. 3 plus negative 3 is 0. I'm not even going to write 0y. I'm just going to cross it off. Those are gone for the time being. So pay attention to the rest of the equation. And we need it in standard form, you guys, so it's all lined up. Like the x's are lined up here. The number on the other side's lined up. So that part's important. But when I add the x's, 5x plus 1x is 6x. The y's are gone. Bring down your equal sign. 23 plus 1 is 24. Now all I have to do is solve what's left, which is super easy. I just divide by 6, and x equals 4. Regardless of the method that you're using, the answer to a system is an ordered pair. So we have the x value. We just need to find the y value. And guys, this part isn't different either. You just bring the x value back up to the system, and you choose one equation to plug it into. For this method, the easier one to plug into, maybe the one with less negatives or the one with smaller numbers. Honestly, these two, it doesn't make a huge difference. I'm just going to choose the second equation, but realize it does not matter. Okay, so the second equation is x minus 3y equals 1. Maybe we'll just copy that right here. I know x. X is 4. So I'm going to plug that in. The parentheses don't make a difference there because there's not a number in front to distribute besides 1. So now I'm just going to solve this for y. So I'm going to subtract 4 and then divide by negative 3. And y would equal 1. Okay, so there's my answer. Realize I could check this if I had the time. I could plug in 4 for x, plug in 1 for y, and make sure that it makes both equations work. All right, let's do another example. So again, the setup is really important. I see that both of these are in standard form, like the x's are lined up, the y's are lined up, plain numbers, so that part's good. Then I just need to make sure that I have either in front of the x's or the y's the same number with opposite signs. And this time I have that in front of the x's. I have positive 6 and negative 6. So that means I'm ready to just go ahead and add the equations together because 6 plus negative 6 is 0. So the x's eliminate. Be careful with your signs here. Like these are both negative 5s, so I have to do negative 5 plus negative 5, which is negative 10y. And then 27 plus 3 is 30. Now I just solve this one-step equation for y, and I get negative 3. So I have the second number of my solution here. I just need to find the x value. So again, I'm just going to bring this back up, and I'm going to pick an equation to plug it into. I'm just going to go for the one with smaller numbers, so I'm going to pick the second equation. Just do my work off to the right here. I know that y is negative 3, so I'm going to plug that in. And then I'm going to solve this for my x value. Be careful right here. This is a negative times a negative, which is positive 15. So just write plus 15. Then I'm going to subtract, and then divide by negative 6, and x would equal positive 2. Okay, so there's my answer. Now, I know you're probably thinking, oh, this maybe is so much easier than substitution. And yeah, I feel like it kind of just clicks for people quicker than substitution, and it may feel like less work, but for some rhyme or reason, substitution is the method that you're going to use for the long haul. Like you'll use that the most throughout this class, geometry and algebra 2. So elimination is important, but it's really substitution that kind of like sticks with us as we move on in the years. All right, example 3. If I look at the setup, they're telling me right here that something's wrong with it. So what I need it to look like for elimination, it's missing something. So again, well, what's wrong with this example? If you look close, I need the same number in front of the x's or the y's, and I do have it with the x's. They're both 2's, but the problem is they're not opposite signs. and I need them to be opposite signs. They have the same sign. So I'm going to say the problem is the 2's are both positive. I need one of those 2's to be a -2 for them to eliminate when I add. So this is important to note. If the coefficients, if the numbers in front of the x's or the y's are not what you need them to be, you can adjust and change things around to make them what you want, and you do that by multiplying. So we can multiply one or both of the equations by a number to make it what we want. So think about what we want. Well, I need one of those to be -2. So watch what I'm going to do. I'm just going to choose the first equation, doesn't matter which one on this example, and I'm going to put the whole thing in parentheses. If I need that to be a -2, all I have to do is multiply it by -1. And then I would have a -2. Whatever I choose to multiply by, though, I have to multiply all 3 terms by that number to keep the equation balanced. So if I multiply all 3 terms by a -1, here's what it now looks like. And I'm just going to write it underneath. It'd be -2x minus 8y equals -28. I basically just changed all of the signs to negatives. All right, I'm going to cross off the equation that I changed, and I'm going to use these 2 now for my system. And now I have what I want. I have 2 and -2, same number, opposite signs. So now I can add the equations together because 2 plus -2 is 0 x's. Those eliminate. Okay, watch your signs. 6y plus -8y is -2y. 22 plus -28 is -6. And then when I divide by -2, I get y equals +3. Okay, so I've got one number in my answer. I have the y value. This part is not any different. I just bring it up top and I choose one of the equations. You have 3 options this time, actually. I'm just going to pick the middle one because it's got all positive numbers, which maybe is a little bit easier to work with. I know that y is 3, so I'm going to plug that in for y and then solve this for x, which that part shouldn't be terribly difficult for us. When I divide by 2, I get 2 for x. Okay, making you work here, but I want you guys to try example 4. Now notice this one's like example 3 where the signs don't match up. I need one of those 3's to be a +3. So see if you could make that happen and then use elimination to get your answer. Now for the word problem. So later this week we're going to really focus on word problems and we're going to do a whole day of just applications. But for now we're going to take it slow with this one. We've kind of already seen a few word problems. This one's not too terrible though, so let's see if we can handle it. Now, again, if I'm writing a system, and while I haven't even read that sentence yet, I'm in the systems unit, so if I see a word problem, I need 2 equations. So this one says, the sum of 2 numbers is 49. The difference between the 2 numbers is 15. I want to find the 2 numbers. So the first thing you want to figure out is, what are your variables? Well, we're just talking about 2 numbers here, so I'm going to be boring and use x and y. Usually the sentences break up where your equations come from. So I can write an equation from this first sentence. Sum means add. So if I add x and y, is means equal, that should equal 49. The second sentence I can write another equation from. So this one says the difference, which that means subtract. So if I subtract x and y, I should get 15. So I've got my system here, and we'll talk about this in the lesson on applications, but when you see a word problem, you can use whatever method you want to solve. So this is where it's good to be confident in all methods, because this one is set up perfectly for elimination. If I just add the equations together, one of the variables is going to eliminate. And all of your coefficients here are 1s. In front of the x's, those are positive. In front of the y's, this is what's going to eliminate because it's positive 1 and negative 1. When I add those together, that's 0. 1x plus 1x would be 2x. And then 49 plus 15, that would be 64. So if I divide by 2, I have one of the numbers. It's 32. So there's half of my answer. I just need to find the second number that they're talking about. So again, let's bring it back up and plug it in. I'm just going to go to the first equation just because I don't want to deal with the negative if I don't have to. I know that x is 32. So all I have to do is subtract that over, and I have the y value, which is 17. All right, that's elimination.